Every single Git repository, no matter how large, started with these exact same 3 commands. Before we touch any code, here's the whole idea in a few facts. Git init creates a brand new, empty Git repository in the current folder. Git add stages specific changes, it doesn't commit them, it just marks them ready to be committed. Git commit permanently saves the staged changes into the repository's history with a message describing why. Creates a new, empty.git folder. This directory is now a real Git repository. Creates a real file with actual content, currently untracked by Git. Shows index.html as an untracked file. Git sees it, but isn't tracking changes to it yet. Stages this specific file, marks it ready to be included in the next commit. Now shows index.html as staged, ready to be committed. Permanently saves the staged snapshot into history with a message explaining it. Init, add, and commit are the exact same 3 steps every Git repository in existence started with: creating the repo, staging a specific change, then permanently saving it with a message. Git init creates a new, empty Git repository in the current folder. Git add stages specific changes, marking them ready to be committed. Git commit permanently saves the staged snapshot into history with a message. Try running Git init in a new folder and making your very first commit. Thanks for learning with us. Come back soon. The staging area is the reason you can change 5 files but commit only 2 of them together. Most beginners never realize it's even there. Before we touch any code, here's the whole idea in a few facts. The staging area sits between your actual files and your commit history. Nothing is committed until it's staged first. Git add moves specific changes into staging. It doesn't touch your commit history at all yet. You can stage and commit changes in deliberate, logical groups, even if you edited many files at once. To completely unrelated changes made in the same working session. Shows both files as modified, neither is staged yet. Stages only this one file, app.js remains unstaged. Style.css now shows as staged. App.js still shows as an unstaged modification. Commits only the staged style.css change. App.js is completely untouched by this commit. A second, separate, logically distinct commit for the unrelated change. Staging one file at a time, instead of committing everything at once, means your history reads as a series of clean, logical changes instead of one confusing bundle of unrelated edits. The staging area sits between your files and your commit history. Git add stages specific changes without touching commit history yet. You can stage and commit changes in deliberate, logically separate groups. Try editing 2 unrelated files and committing each one separately using staging. Thanks for learning with us. Come back soon. A branch lets you experiment freely on a completely separate timeline without ever risking your project's stable main line of history. Before we touch any code, here's the whole idea in a few facts. A branch is just a movable pointer to a specific commit. Creating one is instant and nearly free. Git switch moves you between branches, updating your actual working files to match that branch's state. Git merge brings one branch's commits into another, combining their histories back together. Creates a new branch pointer at the current commit. Main is completely untouched. Moves you onto the new branch. Your working files now reflect this branch's state. Every commit here only affects this branch's history, not main's. Moves back your files instantly reflect main's state, with none of the feature branches changes. Brings every commit from feature login into main, combining the two histories. Deletes the now merged branch pointer, its commits remain safely in main's history. Branching costs nothing, it's just a new pointer to your current commit, which is exactly what makes it safe to experiment freely without ever risking main's stable, working history. A branch is a movable pointer to a specific commit, not a copy of the whole project. Git switch moves you between branches, updating your working files to match. Git merge combines one branch's commits into another, joining their histories. Try creating a new branch, making one commit on it, then merging it back into main. Thanks for learning with us, come back soon. When two branches change the exact same line differently, Git can't guess which version you want. It stops and asks you directly. Before we touch any code, here's the whole idea in a few facts. A merge conflict happens when two branches modify the same lines of the same file in different ways. Git marks the conflicting section directly in the file with less than is equal to and greater than markers. Resolving means editing the file to keep the correct content, removing the markers, then staging and committing it. Attempts to combine the two branches' histories automatically. Both branches changed the exact same line. Git can't automatically decide which to keep. Head shows your version is equal to separates it from greater than feature branches version. Manually choose, combine, or rewrite the conflicting section, then remove all the markers entirely. Marks this specific conflict as resolved, ready to be included in the merge commit. Completes the merge with a real commit joining both branches' histories together. A merge conflict isn't Git failing, it's Git correctly refusing to guess between two genuinely different versions of the same line and asking you to make that one specific decision yourself. A merge conflict happens when two branches change the same lines differently. Git marks the conflict directly in the file with is equal to and greater than markers. Resolve by editing the file, removing the markers, then staging and committing it. Try creating a deliberate merge conflict between two branches and resolving it by hand. Thanks for learning with us, come back soon. Every single change ever made to your project is still there. These 3 commands are how you actually go find it. Before we touch any code, here's the whole idea in a few facts. Git log shows the full commit history, author, date, message, and commit hash for every single change. Git diff shows exactly which lines changed, added, or removed between any 2 points in history. Git blame shows exactly which commit and which person last changed every single line in a file. Lists every commit hash, author, date, and message from newest to oldest. The same history, condensed to 1 line per commit for a quick scan. Shows exactly what changed between the previous commit and the current one. Green lines were added, red lines were removed, an exact, line-by-line record of the change. shows the exact commit and author responsible for every single line currently in the file. Instantly identifies which commit introduced it and who wrote it, no guessing required. Git log, diff, and blame together mean nothing in your project's history is ever truly lost. Every single line can be traced back to the exact commit, author, and reasoning behind it. Git log shows the full commit history with author, date, message, and hash. Git diff shows exactly which lines changed between any 2 points in history. Git blame shows exactly which commit and author last changed every line in a file. Try running git blame on one file in your own project and finding a surprising author. Thanks for learning with us. Come back soon. Committing node_modules or a.un file with real secrets is one of the most common and most avoidable Git mistakes. Before we touch any code, here's the whole idea in a few facts. Gitignore lists file patterns Git should never track or stage, even if they exist in the folder. Dependency folders like node_modules should never be committed, they're regenerated from a log file instead. Files already tracked before being added to .gitignore keep being tracked, ignoring only affects new, untracked files. A dependency folder that's entirely regeneratable from package.jso stages every single one of those 40,000 plus files into the repository. Tells Git to never track anything inside this folder going forward. Node_modules no longer appears at all, completely invisible to Git. Add this to gitignore 2, secrets should never enter version control. Removes an already tracked file from Git's tracking without deleting it from disk. A single .gitignore file keeps regeneratable dependency folders and real secrets out of your Git history entirely, and Git rm cached cleans up anything already committed by mistake. Gitignore lists patterns Git should never track, even if the files exist locally. Dependency folders like node_modules should never be committed at all. Files already tracked before being ignored need Git rm cached to actually stop tracking them. Try checking your own repos .gitignore for whether it excludes node_modules and .un. Thanks for learning with us. Come back soon. Git has at least 3 different ways to undo something, and picking the wrong one can either quietly rewrite history or leave a mess behind. Before we touch any code, here's the whole idea in a few facts. Git checkout file tag discards uncommitted changes to a specific file, restoring it to its last committed state. Git reset moves the branch pointer backward, optionally discarding commits entirely, dangerous on shared history. Git revert creates a new commit that undoes a previous one, safely preserving the full history either way. Changes made locally that haven't been staged or committed at all yet. Discards these specific uncommitted changes, restoring the file to its last commit. Moves the branch pointer back one commit, but keeps all the changes staged. Moves back one commit and discards the changes entirely, use with real caution. Creates a brand new commit that reverses commit even B2C 3DS changes, keeping full history intact. Reset is safe only on local, unpushed commits. Revert is safe on shared, already pushed history. Checkout, reset, and revert all undo something, but only one of them is actually safe once a commit has been pushed and shared. Knowing which is which prevents a genuinely bad day. Git checkout file tag discards uncommitted changes to that specific file. Git reset moves the branch pointer backward, safe only on local, unpushed commits. Git revert creates a new commit undoing a previous one, safe on shared, pushed history. Try making a commit, then undoing it with git revert instead of git reset. Thanks for learning with us. Come back soon. Both combine to branches work, but one preserves exactly what happened, and the other rewrites history to look like it happened differently. Before we touch any code, here's the whole idea in a few facts. Git merge creates a new commit joining two branches, preserving the real, exact history of both. Git rebase replace one branch's commits on top of another, creating a straight, linear history but new commit hashes. Never rebase commits that have already been pushed and shared, it rewrites history other people may depend on. Both branches diverged from the same original point in history. Creates a new merge commit joining both histories, the real, original commits are all preserved. Shows a visible branch and merge shape, the true history of how things actually happened. Instead, replace features 3 commits on top of main's latest commit. A single, straight, linear line, no visible branching at all in the log. They look similar, but are technically different commits, never rebase something already pushed and shared. Merge preserves exactly what really happened, rebase rewrites history to look cleaner, which is exactly why rebase is only safe on commits nobody else has pulled yet. Git merge creates a new commit joining two branches, preserving real history. Git rebase replace commits on top of another branch, creating a straight, linear history. Never rebase commits already pushed and shared, it rewrites history others may depend on. Try comparing git log graph before and after both a merge and a rebase on test branches. Thanks for learning with us. Come back soon. You're mid-edit on a feature when an urgent bug fix comes in. Git stash lets you set your work aside instantly without committing half-finished code. Before we touch any code, here's the whole idea in a few facts. Git stash saves your uncommitted changes and reverts your working directory to a clean, matching head state. Git stash pop brings those exact saved changes back, restoring your working directory to how you left it. Multiple stashes stack up. Git stash list shows every saved set, in case you need to juggle several at once. Real, unfinished work that isn't ready to commit yet. Need to switch branches immediately, but committing half-finished code isn't right either. Saves the uncommitted changes and reverts the working directory to a clean state. Now on a genuinely clean branch, free to make the urgent fix. Back on the original branch, with the exact saved changes restored. Shows every stash currently saved, useful when juggling more than one at a time. Git stash means an urgent context switch never forces you to choose between committing half-finished code or losing your uncommitted work entirely. Git stash saves uncommitted changes and reverts to a clean, matching head state. Git stash pop restores those exact saved changes back into your working directory. Multiple stashes stack. Git stash list shows every saved set currently available. Try stashing an uncommitted change, switching branches, then popping it back. Thanks for learning with us. Come back soon. Your local commits don't exist anywhere else until you explicitly push them. Git is fully offline first by design. Before we touch any code, here's the whole idea in a few facts. Git clone downloads a complete copy of a remote repository, including its full history, onto your machine. Git fetch downloads a remote's latest commits without merging them into your current branch automatically. Git pull is fetch immediately followed by a merge, convenient, but sometimes surprising when you didn't expect a merge. Downloads the entire repository, including full commit history, onto your machine. These commits exist only on your machine until explicitly pushed anywhere else. Uploads your local commits to the remote, making them visible to everyone else. Your local repository has no idea this happened yet, nothing updates automatically. Downloads the teammates' new commits, but does not merge them into your current branch. Fetches and immediately merges, combines fetch and merge into one single command. Clone, push, fetch, and pull are the four commands that turn Git from a purely local, offline history into a genuinely shared, synchronized project everyone works from together. Git clone downloads a complete copy of a remote repository, including its history. Git fetch downloads new commits without merging them into your current branch. Git pull is fetch immediately followed by a merge, combined into one command. Try running git fetch on your own project and checking what it downloaded before pulling. Thanks for learning with us. Come back soon. A pull request isn't just merge this, it's a real conversation about a specific set of changes before they ever reach main. Before we touch any code, here's the whole idea in a few facts. A pull request proposes merging one branch into another, opening a dedicated space for review and discussion first. The Files Changed tab shows an exact diff of every line added, removed, or modified across the whole branch. A PR can be updated with new commits after opening. Reviewers see every new push added to the same conversation. Pushes your branch to the remote required before a PR can be opened for it. GitHub automatically detects the newly pushed branch and offers to open a PR. Explains what changed and why, essential context for whoever reviews it. Shows the exact diff every added, removed, and modified line across the entire branch. Opens the PR now visible to the whole team, ready for review and discussion. Automatically appears in the same PR. Reviewers see every new update as it happens. A pull request turns I merged some code into a real, visible conversation, a title, a diff, and a space for teammates to actually discuss the change before it ever reaches main. A pull request proposes merging one branch into another, opening it for review first. The Files Changed tab shows an exact diff of the entire branch's changes. New commits pushed after opening automatically appear in the same PR conversation. Try opening a pull request for one small change in your own repository. Thanks for learning with us. Come back soon. A good code review isn't just looks good. GitHub gives reviewers line-specific comments, direct edit suggestions, and a real approval workflow. Before we touch any code, here's the whole idea in a few facts. Reviewers can comment on one specific line of a diff, keeping feedback precisely tied to the exact code it's about. A suggestion block lets a reviewer propose an exact replacement, which the author can apply with a single click. A formal review submits as approve, request changes, or comment. Each carries a different real meaning for the PR. Shows the full diff, ready for line-by-line review. Opens a comment box tied precisely to that one line, not the PR as a whole. Feedback that stays permanently attached to this exact line, even as the PR evolves. Proposes the exact replacement code. The author can apply it with a single click. A formal signal, this PR should not be merged until these specific points are addressed. The reviewer sees exactly what changed since their last review, in context. Tying a comment to one exact line, proposing a real suggestion block, and submitting a formal approve or request changes turns code review from a vague opinion into a precise, actionable conversation. Reviewers can comment on one specific line, keeping feedback precisely tied to the code. A suggestion block proposes an exact replacement the author can apply with one click. A formal review of approve, request changes, or comment carries distinct real meaning. Try leaving a line-specific suggestion on your own or a teammate's next pull request. Thanks for learning with us. Come back soon. Without a shared place to track them, bugs get reported in a chat message and forgotten within the hour. Before we touch any code, here's the whole idea in a few facts. An issue is a single, trackable unit of work, a bug report, a feature request, or a task with its own discussion thread. Labels, assignees, and milestones let a large backlog of issues stay organized and filterable at scale. Referencing an issue number in a commit or PR, like fixes number 42, automatically links and can auto-close it. Opens a fresh, trackable unit of work with its own title and discussion thread. A specific, searchable, permanently referenceable description of the problem. Makes this issue filterable and sortable alongside dozens or hundreds of others. Makes clear exactly who owns investigating and fixing this issue. References the issue number directly in a real commit message. GitHub automatically closes issue number 42, the link and resolution are fully traceable. A single fixes number 42 in a commit message links a real fix directly to the original bug report and closes it automatically the moment the fix merges, nothing gets silently lost. An issue is a trackable unit of work with its own title and discussion thread. Labels, assignees, and milestones keep a large backlog organized and filterable. Referencing an issue number in a commit or PR can automatically link and close it. Try opening a real issue for one small improvement you've been meaning to make. Thanks for learning with us. Come back soon. Without branch protection, anyone with write access can push straight to me, skipping review and breaking the build entirely. Before we touch any code, here's the whole idea in a few facts. A branch protection rule can require at least one approving review before a PR is allowed to merge at all. Required status checks block merging until CI tests, linting, builds actually passes. Even repository admins can be included in these rules, so no one accidentally bypasses the safety net. Creates a new protection rule targeting a specific branch, typically main. Direct pushes to this branch are now blocked entirely. Every change must go through a PR. At least one teammate must formally approve before the merge button becomes available. CI must finish successfully, tests, linting, build before merging is even possible. The merge button stays disabled. GitHub visibly shows which specific check failed. Applies the same rules to everyone, with no bypass, even for repository admins. Branch protection turns please review before merging from a polite request into an actual enforced rule, one that even applies to repository admins if you choose to include them. A protection rule can require at least one approving review before any merge. Required status checks block merging until CI actually passes. Including administrators means no one bypasses the rule, even with full repo access. Try setting up a branch protection rule requiring one review on your own repo's main branch. Thanks for learning with us. Come back soon. You can't push directly to a project you don't own. Forking gives you your own full copy to work in safely before proposing changes back. Before we touch any code, here's the whole idea in a few facts. Forking creates your own complete, independent copy of someone else's repository under your own account. You clone your fork locally, make changes, then push them back to your fork, never the original repository. A pull request from your fork to the original repository is how you propose your changes back to the maintainers. Creates your own complete, independent copy of it under your own GitHub account. Clones your fork, not the original repository, onto your machine. Standard local workflow, exactly as if it were your own project. Pushes to your fork's remote, the original repository is completely untouched so far. GitHub lets you propose merging your fork's branch into the original project. The original project's owners decide whether your proposed change gets included. Forking gives you a complete, independent copy to freely work in, and a pull request from that fork back to the original is the standard, respectful way every open source contribution gets proposed. Forking creates your own complete, independent copy of someone else's repository. You clone and push to your own fork, never directly to the original repository. A PR from your fork to the original repo is how you propose changes back to maintainers. Try forking a small open source project and opening your first pull request to it. Thanks for learning with us. Come back soon. Every single push can automatically run your tests, check your code style, and even deploy without you ever running a command by hand. Before we touch any code, here's the whole idea in a few facts. A workflow file in .github workflows defines exactly what runs and on which events, like every push or pull request. Each job runs a series of steps, checking out code, installing dependencies, then running your real test suite. A failing step blocks the workflow and shows up directly as a status check on the associated pull request. A new YAML file defining exactly what this workflow does and when it runs. Triggers this workflow automatically on every push and every pull request. The first 3 real steps, getting the code and its dependencies ready to test. Runs your actual test suite exactly as it would on your own machine. GitHub automatically starts the workflow, visible live in the Actions tab. Shows as a real status check, green for pass, red for fail, directly on the pull request. One workflow YAML file means every future push and pull request automatically gets your real test suite run against it, no one has to remember to do it, and no broken code slips through unnoticed. A workflow file in .github workflows defines what runs and on which events. Each job runs real steps, check out, install dependencies, then run tests. A failing step shows directly as a status check on the associated pull request. Try adding a basic GitHub Actions workflow that runs your project's test suite on every push. Thanks for learning with us. Come back soon. A commit hash is a random string nobody remembers. A tag like version 2.1.0 gives that exact same point in history a real, memorable name. Before we touch any code, here's the whole idea in a few facts. A tag is a permanent, named pointer to one specific commit. Unlike a branch, it never moves. Semantic versioning, major.minor.patch, communicates exactly what kind of change a release contains. A GitHub release wraps a tag with real release notes and can attach compiled build artifacts for download. Creates a permanent, named pointer to the current commit, this exact point in history. Lists every tag in the repository, a readable history of every past release. Tags aren't pushed automatically with commits, they need this explicit push. Major, breaking changes. Minor, new features. Patch, bug fixes only. Wraps the tag with real, human-readable release notes describing what changed. Lets users download the exact compiled output for this specific release directly from GitHub. A single Git tag turns a random, unmemorable commit hash into a permanent, semantically meaningful version number, and a GitHub release wraps it with real notes and downloadable build artifacts. A tag is a permanent, named pointer to one specific commit. Unlike a branch, it never moves. Semantic versioning, major.minor.patch, communicates exactly what kind of change a release contains. A GitHub release wraps a tag with human-readable notes and downloadable build artifacts. Try tagging your current commit as version 1.0.0 and pushing that tag to your remote. Thanks for learning with us. Come back soon. You need exactly one commit from another branch, not the whole thing. Cherry-pick copies just that single change over. Before we touch any code, here's the whole idea in a few facts. Git cherry-pick applies one specific commit's changes onto your current branch as a brand new commit. It's ideal for backporting a single critical bug fix to an older release branch without merging everything else. The cherry-picked commit gets a new hash on the target branch. It's a genuine copy, not a shared reference. One specific, urgent commit that needs to reach an older release branch too. Find the exact commit hash of that one specific fix. Move to the older release branch that also needs this fix without any other changes from main. Applies only that one commits changes onto this branch, nothing else from main comes along. The fix is now present here too, as a genuine new commit with its own hash. The commit might not apply cleanly if release 1.x has diverged, resolve exactly like a merge conflict. Cherry-pick copies exactly one commits changes onto a different branch, which is exactly what you want when backporting a single urgent fix without bringing along everything else main has moved on to. Git cherry-pick applies one specific commit's changes as a brand new commit. It's ideal for backporting a single fix to an older release branch. The cherry-picked commit gets a new hash. It's a genuine copy, not a shared reference. Try cherry-picking one commit from one branch onto another in a test repository. Thanks for learning with us. Come back soon. You don't need a hosting bill to put a real, live site on the internet. GitHub will serve static files straight from your own repository, free. Before we touch any code, here's the whole idea in a few facts. GitHub Pages serves static HTML, CSS, JS files directly from a repository at a real, public URL. It can build from a specific branch or from a dedicated docs folder, depending on how you configure it. A custom domain can point at GitHub Pages, so the free hosting doesn't have to show a github.io URL at all. A real, working static site, currently sitting unpublished in the repository. Tells GitHub exactly which branch to build and serve as a live site. No server to configure. GitHub handles the actual hosting entirely. The real, live, publicly accessible URL for the exact same files in your repo. The live site updates automatically, no separate deploy step required at all. Points your own domain at GitHub Pages, hiding the default github.io URL entirely. GitHub Pages turns the exact files already sitting in your repository into a real, live, publicly accessible site with no separate hosting bill and no manual deploy step after the first setup. GitHub Pages serves static files directly from a repository at a real public URL. It can build from a specific branch or a dedicated docs folder. A kname file lets a custom domain point at Pages, hiding the default github.io URL. Try enabling GitHub Pages on one of your own repositories and visiting the live URL. Thanks for learning with us. Come back soon. A README is often the only thing standing between someone discovering your project and either using it or leaving in 30 seconds. Before we touch any code, here's the whole idea in a few facts. A great README answers, in order, what is this, why does it matter, and how do I actually run it? GitHub automatically renders readme.md on the repository's front page. It's the real first impression. A contributing.md sets clear expectations for how outside contributors should propose and format changes. A clear, single-line title, the very first thing anyone reads. Answers what is this and why should I care in the first few seconds of reading. Exact, copy-pastable commands to get the project running locally, no guessing required. Shows, concretely, how the project is actually used, not just described abstractly. GitHub automatically renders this file directly on the repository's front page. Sets clear expectations for branch naming, commit style, and the PR process for outside contributors. A README that answers what, why, and how to run it in the first 30 seconds is often the single biggest factor in whether anyone actually gives your project a real chance. A great README answers what this is, why it matters, and how to run it in that order. GitHub automatically renders readme.md on the repository's front page. Contributing.md sets clear expectations for how outside contributors should propose changes. Try rewriting your own project's README to answer what, why, how in the very first section. Thanks for learning with us. Come back soon.